Welcome to On Chemistry. Always try to do your best. Now let us see about 100 conversion in organic chemistry. We are seeing it as episodes. This is the episode number 95. If you didn't watch previous episodes, I encourage you to go and see. Here we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The starting material is benzaldehyde. You are using the benzene as a solvent and you are using phosphine which is attached with ethyl. You have to find the two answers, which is P and Q. One is intermediate, another is product. Here 4 choices are given. The choices are cis alkene or trans alkene. You can say E alkene or Z alkene, and the intermediate which is in the staggered form. The position of aryl group and hydrogen. Whether the aryl group is cis to ethyl group or trans to ethyl group. Here confirmations are given. The intermediate dictate the product, so you have to guess which product is which. So from the phosphine you might guess naming reaction is involved, and definitely configuration is the real question here. The answer is A. Let us see how. The starting material you have phosphine which is halide. Halide you can write it as positive and negative charge. The negative charge near the carbon. The carbon attached with the ethyl group which is electron donating group. Normally the electron donating group destabilizes the anion. So the halide is unstable. Then you are reacting halide with aldehyde. Halide possesses the negative charge. Negative charge attacks the carbonyl there. So negative charge attacks the carbonyl. You have new CC bond. So new CC bond is formed. You have the charges. How the charges will be quenched? That is the intermediate comes here. The intermediate you have drawn in staggered form. The elimination is the anti-elimination here. So phosphine and oxygen should be anti to each other. Normally the reaction is very quick. So the elimination is Z form. If the stabilized halide means the reaction will be very slow, the product will be thermodynamic product. Here it is a kinetic product. So you have Z form as the product, both benzene and ethyl in the same side. Here the side product is PH3PO. Here you have to learn 2 important things. One is Wittig reaction. The Wittig reaction is important because it converts C double bond O into CC bond. Second thing is stability of halide versus product alkene. Unstable halide means you have Z form, you can say cis. Stable halide means you can have E form which is trans. So the halide dictates the final product configuration. Let us see the question number 2. The starting metal is anisole which is attached with methyl and the para position. You are using lithium and ethyl alcohol and ammonia. Next step you are using ozone with methane and methyl sulfide. They ask you to find the product. The products are most ring is open and aromaticity is destroyed. Where the ring is open is the question here. The ring is open near methoxy group or the methyl group or just oxidation reduction at the same time, or the groups are completely oxidized or partially oxidized. And the other question is where the aldehyde and ketone is forming. So how the ring open and which way ring open is question here. So from the reactant to product you might guess loss of aromaticity definitely occur. Regioselective ring opening is the real question here. The answer is D. Let us see how. The first step you are using benzene with lithium ethyl alcohol and ammonia. This reaction is basically called bridge reduction. In bridge reduction the double bond formed near the electron donating group. Here electron donating groups are methoxide and methyl. Normally the 1,4 double bond is formed, which is formed near me. This is the only possibility. So the reduction occurs. Next step is ozonolysis. Ozonolysis open the ring, but where the ring will open is the question here. Ozonolysis, the ozonate formed in the electron rich position. Here methoxide is a very good electron donor because of its oxygen. Because oxygen mesomerically donate the electron, increase the electron density. So methoxide is a very good electron donating group. Ozonolysis happen near the methoxide. So the ring is open. Already methoxide is there. The double bond become 2CO group. So MEO become ester there. So COO-ME. And another become ketone there, which is answer clearly D. Here you have to learn 2 important things. One is bridge reduction. Bridge reduction is a curious reduction because it reduces the benzene and decreases the aromaticity. but double bond formed near the electron donating group. Second thing is ozonolysis. Ozonolysis can occur at any double bond, but more preferably electron rich double bond get ozonized. So here methoxy group get ozonized, and finally you have ester and aldehyde there. Then the question number 3. The starting metal is cyclohexane attached with methyl group. You are using NBS and AABN. They ask you to find the product. The products are mostly brominated one, where the bromination occur. Bromination occur in the side chain, or in the fourth position, or in the second position, or in the first position. Here the bromine attack and its position is important. So from the reactant to product you might guess where is the reaction center where the bromine will be attached. The answer is D. Let us see how. The starting metal you are using NBS, which having weak N and Br bond because of bulkiness of bromine and the radical stability. Here you are using AABN, which is the radical initiator. Here you are using the AABN, which is the radical initiator, which is initiate the radical in the system. So the weak bond NBr breaks, so N radical and Br radical form there. The Br radical again attack in the system. But where the radical will form in the system, that is an interesting question. There are the 4 possibilities, that's what they given in the answer. The side chain form tertiary radical, and the alpha position form the secondary radical, and the fourth position form the secondary radical, and the attached first position form the tertiary radical, and the methyl position form the primary radical. So there are the many radical possibilities, but we should know radical stability tertiary is more stable than secondary than primary. So the major will be the first one, which is tertiary. There the bromine attacks, you have the final product D, which is first position attached bromine. So methyl and bromine attached to the same carbon. Here you have to learn 2 important things. One is AABN and NBS. If you have AABN and NBS, you have to imagine it's a radical donor. You are getting the Br radical. Second thing is intermediate radical. Whenever you have many possibilities, you think of radical stability. The radical stability tertiary is more stable. So you have to proceed the reaction from the tertiary radical. Then the question number 4. The starting metal is linear system, which is attached in the second position alcohol and methyl. You are using sulfuric acid and 180 degree temperature. They ask you to find the product. The product can be of elimination or the cyclization. The elimination 3 possibilities. The methyl hydrogen get eliminated, which is alkene. Third one is the rearranged product, which is third and fourth carbon gets eliminated. You have product D, and product B is the cyclized one. So from the reactant to product you might guess the ring closure there is a possibility. Otherwise the competition of ring closure versus elimination is there. The answer is C. Let us see how. The starting metal you are having alcohol, you are using sulfuric acid. So what really happened is sulfuric acid protonate the alcohol. Protonate the alcohol, and what really happened is it become like water. So water is a good leaving group because of its neutral form. So water leaves, you have cation formation. So cation is formed. Here the real question, whether the rearrangement is occur or not? No, because the already stable cation is there, which is tertiary cation. Then the elimination or cyclization. You are using very high temperature, only elimination is possible. Elimination there are 2 possibilities, which is A hydrogen elimination or B hydrogen elimination, or you can say end hydrogen elimination or middle hydrogen elimination. End hydrogen is the minor product, middle hydrogen is the major product because CSIR rule. CSIR rule says that more substituted product will be formed, the more substituted alkene, which is product C. Here you have to learn 2 important things. One is high temperature. High temperature favors the elimination, not the cyclization. Second thing is CSIR product. CSIR product means more substituted alkene will be formed rather than less substituted product, because more substitution is the thermodynamically stable product, which is the CSIR form. Then the question number 5. The starting metal is diazomethane. You are using light and acetophenol. You have the product. Then the next step you are using the alkene, which is in the cis form. Then you have another product. So you have to identify P and Q. So you have the possibility, which is the P, which is carbines are mentioned, which is triplet carbene or singlet carbene, and Q, cyclopropane, which is in the cis form or trans form. So here are the four possibilities. Whether there can be singlet carbene formation or triplet carbene formation, or cis dimethylpropane or trans dimethylpropane, or mixture of it. From the reactant to product, you might guess intermediate definitely play the role here, and stereochemistry of final product is important. The answer is D. Let us see how. The starting metal you are having diazomethane, you are using the light, there is a formation of carbene here. When you are using the acetophenone, there will be the triplet carbene formation. The standard synthetic procedure for triplet carbene formation, and you are reacting triplet carbene with alkene. So what really happens is ring closure occurs there. So the cyclopropane ring is formed. But triplet carbene can rotate freely because of its single bond. So there can be equal possibility of cis and trans. That's why mixture of product is possible. Which is the possible choice, which is the product D, because P is the triplet carbene, Q is the mixture of product. Here you have to learn two important things, which is triplet carbene formation. Whenever you have acetophenone with light and diazomethane, you have triplet carbene. Second thing is triplet carbene with alkene always create the mixture of product, which is cis and trans. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.